Welcome everyone. So today we'll be learning about data types in C programming. In the previous video we saw what are variables and how can we define and declare variables in C programming. Now one thing we saw when defining a variable is that we always have to mention the data type of a variable. That is basically the type of data a variable can store. In this lecture we'll be learning about data types in detail. What does a data type do and what is its role in programming? So let us begin. So data types basically they help in defining four things. The first thing being the size of the data a variable can store. The second is the layout of variables in the memory. Third is the range of values a variable can store, and also the set of operations that can be performed on a variable or memory. So this is what a data type does. It determines the size, the layout, the range, and the operations that can be applied to a variable. Now in the previous video we saw the syntax of defining a variable. Now let us see the same syntax again here. So whenever we define a variable, first we mention the data type and then the identifier, which is the name of the variable. Let's take a simple example. Let's say int a. Now what does int a mean? Here a is the identifier, that is the name of the variable, and int is the data type. So what is the role of int here? The data type int. So the data type int basically tells me that a can only store integer values. Okay, it can only store integer values. It means that it cannot store floating point or decimal values or any character value. Thus int can only store integer values. Okay, a can only store integer values. It also tells me the size and the range. In this case, a can store a 4-byte integer value or a 2-byte integer value. Now this also depends upon the architecture of the machine, the size of a data type. We will see that in some time how the architecture of a machine, that is a 64-bit machine or a 32-bit operating system, what is the default size of a data type. Now let us see how data types are classified into different categories. Now when it comes to data types, they are divided into three categories: primitive data types, derived data types, and user-defined data types. Today we will be focusing mainly on what are primitive data types. Now primitive data types are basically, they are the fundamental types that are built into the language. So one keyword to remember here is fundamental. That is, they are the very basic data types that are already built into the language, and they are predefined and serve as a building block for data manipulation. Under primitive data types, we have four types, which are integer, characters, float, and void. Now integer is used to deal with integer numbers, that is your numbers from the negative infinity to positive infinity. Okay, it even includes 0. Then we have character values. These can be alphabets such as A, B, C, D, so on. Then we have float, which is for single precision floating point numbers, that are decimal numbers, for example 1.23. Okay, and last we have is the void data type, which is basically used in functions that don't return a value, or where it returns nothing, that is void. Then we come to derived data types. Now derived data types are basically built upon the primitive data types. Okay, they are built or derived from the primitive data types. So basically they do not define any new data types, but instead what do is they extend the capability of primitive data types. They extend the capability of primitive data types. And how do they do this? They do this by often grouping multiple elements of a primitive data type together. Let's take the example of an array. So an array can also have a data type. For example, when I define an array such as int arr 5. Now I know array is not a topic which we'll be covering today, but just a small glimpse of what an array does is, whenever I define an array, let's say an integer array, what happens is, in my memory I am allocating some space. Now this space depends upon the size of the array. In this case, my array is of size 5. That is, it can store 5 integer values. Let's say 10, 20, 30, 40, 50. It is storing 5 integer values. Now, one thing we need to keep in mind here is that we cannot give a value of decimal, let's say 50.2, or a character value, because this is an integer array, which means that this array can only store integer values. That's one thing we need to keep in mind. Also, the size of this array will be based upon the size of an integer and the number of elements the array stores. So let's say if an integer is 4 bytes, okay, on this machine. So 4 into 5 will give me 20. So my array can store 20 bytes of data, okay. That is, a memory of 20 bytes will be allocated in memory, okay, in the memory. So that topic we'll be covering later, but this is what a derived data type does. It basically groups multiple elements of a primitive data type to create more complex structures, and they are derived from the primitive data type. So under derived data type, we have arrays, strings, pointers, which we'll be covering in separate videos. And then we have the most used data types, that is the user-defined data types. Now, what are the user-defined data types? Whenever we deal with data structures, we deal with a lot of user-defined data types, such as structures, unions, type defs, and enums. Now, what is a user-defined data type? Now, user-defined data types are basically data types that are defined by the programmer. They are defined and created by the programmer. Now, how does a programmer do this? Basically, by a programmer defines their own user-defined data type based on primitive and derived data types. So using a combination of primitive data types and derived data types, a user or a programmer can create their own user-defined data type. Now, they are used to create complex data structures by combining different types into a single entity. We will see that when we are learning about structures, unions, type defs, and enums. So since today we'll be focusing more on what are primitive data types, let's go ahead and see how primitive data types are further divided into other different kinds. Now, primitive data types. There are 4 different primitive data types, like I told you, that is integers, characters, floating point numbers, and void. So these are further divided into different categories based on something called as modifiers. Now, what do modifiers do? Basically, they are used to alter the size and range of basic data types. So let us look at the size first, and then we'll speak about the range. Now, when it comes to integers, there are 4 different modifiers. That is short int, the normal int, and the long int, and the long log. Now, let us speak about the size. When it comes to short integers, in all machines, the short has a size of 2 bytes. Short integer has a size of 2 bytes. Now, when it comes to the integer data type, that is a normal integer data type, this can either be 2 bytes or 4 bytes. Now, this depends upon the architecture, like I had mentioned. In a 32-bit machine, an integer can take 2 bytes, whereas on a 64-bit machine or architecture, an integer can take 4 bytes. Now, this is machine dependent, and we can't do anything about it, but it is not fixed and it varies from the machine to machine architecture. The long data type 2 can take either 4 bytes or 8 bytes. This also depends upon the machine architecture. Now, I won't be giving the values for of all the sizes. Okay, I won't be specifying all the sizes in this diagram. In fact, what I have done is I have created a table here specifying the size of each data type based on different architectures. As you can see here, on a 32-bit machine, a character is 1 byte, and even on a 64-bit machine, a character is 1 byte. Okay. If we look at the long integer can be 4 byte on a 32-bit machine or 8 bytes on a 32-bit machine. So this table will summarize all those values. Now let us try to understand the range. Now when we speak about range, our range depends upon the type of primitive data type. that is whether it is signed or unsigned. Now every primitive data type can be divided into signed or unsigned. That is, when I speak about signed, what I mean that is that my variable can either take positive values or negative values. Whereas if I define a data type as unsigned, it means that my variable can only take positive values. So this is what I mean by signed and unsigned. So in case of signed, my variable can store both positive and negative values, but in case of unsigned, I can only store positive values. Now let us see how does this help us in defining the range of a variable or the range of values a variable can take. So let us take the example of a character. We all know that a character is 1 byte, right? A character is 1 byte. So how do we find out the range a character can take? It's very simple. Since 1 byte consists of 8 bits, we will use the modulo arithmetic, that is 2 raised to n. Here n is the number of bits. So since a character is 8 bits, the range a character can take is 2 raised to the power of 8. That is how much? 256. So if we include the value 0, which is in this, which comes in the unsigned range, our range can be from 0 to 255. Now this is the range for an unsigned character. Similarly, if we want to find the range of a signed character, what we can do is we can divide, let's say 256 divided by 2. This gives us 128. Now, if we also include the value 0 here, what will happen here is my range will be from minus 128 to 127. This will be my range for signed character values. Similarly, I can find the range of every other data type by using this simple formula, that is 2 raised to n. Now, I won't be doing all the calculations here. I have already done it and I've summarized it in this table. So I will provide this table in the description box. I will give you a link. You can refer to this table. One thing you need to remember when programming is you don't have to remember this entire table. The only thing you need to remember here is mostly the size of the data type based on the machine you are working on. Okay, you need to know that on a 64-bit machine, what will be the size of a character? Let's say 1 byte. And the other thing you need to remember here is that the format specifier. Okay, like how can we, if we want, let's say if we want to print the character on the screen. So what format specifier will I use? In case of characters, it is %c. For an integer value, it will be %d. That is an unsigned integer. That is a signed integer value. In case of unsigned integer values, it will be %u. This is what I need to remember as a programmer. So you can refer to this table in order to know what will be the size and the format specifier of a particular data type. Okay. Now, coming to the range of a particular data type. Like I said, depending upon the size, we can also find the range of a data type. If a data type is 1 byte, it can take the range minus 128 to 127 for signed values and 0 to 255 for unsigned values. Similarly, if it is 2 bytes, it can take this range. For 4 bytes, it will take this range. Now you don't need to remember these ranges. And obviously, if you want to find the minimum and maximum range of any data type, we have some libraries present in C programming. And these libraries, standard header libraries, are the limits.h and the float.h header files. Now let us write a small program to summarize all this and understand what values can we store using a particular data type, and we will also see the minimum and maximum value of that data type, that is the range of that data type, using these two libraries. So I'll go ahead and open my Visual Studio Code, and let's begin by writing the program to print the minimum and maximum range of a data type. Okay, so I will create a new program, range.c. Okay, So let's begin by first including the necessary header files which we will require. Like I told you, we will require the stdio.h, that is the standard input output.h, which will give us the access to the printf function to print the output onto the console. Then we will have the header file for limits.h and float.h, which will basically give me the range, that is the upper and lower limit of my data type. We'll have a main function here. Okay, so let's go ahead and print the size for each and every data type. Let us begin with the first data type, that is integer. So for integer, let's first print the size of an integer. Now in C programming, we have a function called as size of. Now size of will basically it will return to me the size of a data type or a variable in C programming. So let's say size of integer, which is %d bytes. Okay, size of int. This will give me the size of an integer value. Uh, let's print the minimum value. In this case, the minimum value, we will use the constant which is present in the limits.h file. We will use the content int underscore max. If you want to see where are these constants present, you can just open this header file and you will find the values defined here. Okay. We won't be focusing on this. As you can see, the range is already mentioned here. Then we'll print the maximum value of an integer. Oh, sorry, just a small mistake here. For the minimum value, we'll have int min. Similarly, what we will do for each and every data type, we will print the size and the range, minimum, maximum. So I will mention this here. Let's take character next. Size of char. Here I will have character min, and here I will have character max. Let's print the size for float. Okay, the float data type. Here we will have FLT min, float min, float max. Okay, and so on. Let us also cover some other basic data types too. Let us take short integer. Now the integer value which I have taken here, this is unsigned integer. Okay, I have not taken the signed integer, the unsigned integer. Sorry, I mean the signed integer, not the unsigned. So this will print the size and range of signed integer. Similarly, here also we'll be dealing with all signed values, not unsigned values. Okay, size of short, short max. Okay, We'll just leave this for here, or we can just cover one more. We'll cover long integer just to clear our concepts. Since this will have a bigger range, I have used the LD format specifier, that is to print long integer values. Okay, so if there's no doubt, we'll go ahead. Yeah, for float we will have to mention the decimal, that is the floating value. We cannot, okay, sorry, just a second. Where is float? Yeah, we cannot use percentage d here. We'll have to, since we have to find the range of floating point numbers, we'll use percentage e. Okay, for this let us use long unsigned, so that we have enough space in case the val they have a huge size. Then okay, so our program is ready. Let's go ahead and print it, run it, sorry, and return 0. So we're good to go. Let's go ahead and compile the program. Let's run it. Okay, so let's have a look at the output. What output have we got? So for integer, the size is 4 bytes, the minimum value is this much, and the maximum value is this much. Okay, so since we are running the program on a 64-bit machine, the integer value is 4 bytes. Okay. Even on a 32-bit machine, it is 4 bytes. That we will see later. How do we get these values? For character, it is minus 128, and the maximum value is 127. Floating point, 4 bytes. A short is 2 bytes, long is 4 bytes, as we can see. So there's just another small topic which we need to cover, which is overflows and wraparounds. Now we learned about how we can find the range, the minimum value and the maximum value a data type can take, and also about the different sizes of the different data types. Now here we will see what happens if we try to print a value that is greater than the size or the range specified by that data type. So let's take the example of a short integer value. Okay, short int. We all know that this is 2 bytes since we have learned this. And in case of unsigned short and signed short, the range will be, for unsigned, the range will be 0 to 65,535. Whereas for signed short, the range will be minus 37,000, minus 32,768 to 32,767. Okay, this will be the range for the signed integer value. Okay, so let's take an example. Let's plot this on a circle. Okay, let's say this is 0. If we go clockwise, this will give me the range of all positive values, that is 1, 2, 3, and up to the maximum range, which is 32,767. Okay, and similarly, if we go clockwise, anti-clockwise, what we'll do, we'll plot the negative values, that is minus 1, minus 2, minus 3. Now you will understand in some time what am I actually doing here, and the maximum negative value, that is 32,768. Now what happens if I try to print the value 32,768. As we all know, the maximum positive value in a signed short range is 32,767. But what if I want to try to print this? What will happen? So let's try this out with the help of a program. So let's take an integer short x is equal to 32,768. This is the value I want to print, right? And let's try to print this value. If I say printf %d and the value x, let's see what do we get. Okay, now here what am I doing? I am printing the signed value for 32,768. So let's save this. Let me just compile this. And if I run it, you can see what am I getting here? I am getting the value 32 minus 32,768. Now where did this value come from? Okay, let's try something else. Let's try printing the value. Short y is equal to 30,769. What happens if I try to print this now? Let's see, %d. Let's print the value y. Okay, I will compile this. Let's run it again. Oh, so look what we have got here. For the first value, that is 32,768, I got negative 32,768. For the other value, 32,769, I've got negative 32,767. So what is happening here is we have encountered a condition called as overflow or wraparound. So when I'm trying to print a value that is greater than the maximum positive value in a signed short integer, what is happening is it is overflowing. So we are basically printing the next value, which is the negative value, the 32,768. This is how we got negative 32,768 and negative 32,767. So basically we have jumped on to the negative range. So this is what happens when we try to print a value that is greater than the range, as you can see in this case. Okay, the same thing can be said for unsigned integer values. So if this is 0, the maximum is 65,535, right? This is for unsigned short. What if I try to print 65,536? Let's try that. So if I say unsigned short, okay, unsigned short x is equal to 65,536. Let's try to print this. Let's see what we get. So let me give a hint. You will be expecting 0, right? So let's see, do we get that value? If I go ahead and compile this program, sorry, just a small error. Okay, it's just a warning, so that's not a problem. As you can see, we got the value 0. Okay, so this is called as overflow or wraparound. So that's all for today. Let's see, I'll see you in the next lecture where we'll be talking about constants and functions. Okay, so that's all for today. Thank you. Goodbye.